Hey YouTube, JP Dillon. So this is going to be part 3 of the General Electric CYA7342. Previous video we replaced the high voltage focus divider and we did all the setup adjustments as far as grayscale and purity and all that. But there's still one problem that remains, and that of course is that there's no sound. And so we've already determined it's not the speaker in the first video, because we substituted a speaker and that didn't fix it. This little guy here is okay. So the way that the sound works is you've got your audio detector circuit here, and then you've got this little preamp IC which then feeds into a transistor which is down here, this little guy, this TO66 type thing, that then feeds into the output transformer and then finally to the speaker. So somewhere in that chain of things something has failed. Now the fact that we don't get any hits or anything would tend to suggest final stages, but you really don't know. And this says that there's B voltage on it. Ooh, scary, even though it's isolated from the rest of it. So they're not isolating the transistor from the heatsink, and it's just kind of there. So the first thing I want to do is disconnect this little pin plug here after making a locating mark on it, and then we can test to see if the transistor is open or shorted, and also out of circuit. That should allow me to test the primary winding of this output transformer down here. So let's get to that. Okay, so we're going to cut this little tie back here. They probably just put that there because they didn't want it to ever come apart. And let me grab a pen, and we're going to make a little locating mark. And even though there's a clip there, I know me, and I know that somehow I will mess this up. So let's make a locating mark. And then we'll pull the little connector off the transistor, like this. And so that now exposes the transistor there. And the case or collector is at the heatsink, so we can just use that. I'm going to assume they're using an NPN. So I'm just going to get my meter and put it on junction test. And we'll hook one up here. Hook the other one up here. Open in one direction. Let's reverse the polarity. Okay, so there's a junction. So based on where those pins are located, this is an NPN. Let's do base collector. Yep. Alright, so base emitter and base collector junctions are alive. Let's see if there's a short between collector emitter. And there is not. So that transistor, in theory, is still perfectly good. Let's just reverse the polarity just to make sure there's not a defect. I doubt there is. Okay, so the transistor is fine. So the next thing we have to look at is the resistance of the primary of this little transformer down here. And you can see that they've got that in series with the collector of the transistor here. Ah, there's something interesting. If I go between chassis ground and the heatsink with my ohm meter, we can hear crackling in the speaker. So that tells me that very likely this transformer is alive. In fact, if I connect it down here to this terminal, you can hear the current of my ohm meter going through the transformer. So the primary of the transformer is alive, and the little transistor is alive. So that eliminates two of the major probabilities. which is both good and bad. Because really the only thing that's left is this IC here, which is like a preamp IC. And it could be one of these resistors feeding it, or feeding the B voltage supply is open. It could be the 4.5 megahertz detector coil is open too, which would suck. And then we've got this stuff here. Now I can pull this board out. It's just these two here. Then I've got this kind of wired in. This should all just pop out. So let me get the board out and let's check over some things real quick. Alright, so here's our cute little module. This is your IF and your sound, pretty much everything here. Let's check for the obvious dead connections here at the edge connector. I don't see anything obvious that stands out there. There's probably a lot of stuff underneath this shield. See if I can shine a light in here and take a look and see if there's anything obvious underneath this shield. It's not going to focus, but that's okay. Nothing obvious stands out as being busted loose. The detector transformer still looks like it's in there. So the next thing I'm going to do is clip on to ground, which are these shields, and then take a look at the pins of the IC and see if there's any shorts to ground. I also want to see, before I do that, let's see if I can look up this IC. It's a 274.7849, or maybe it's an 1179. Who knows? Let's look up that chip and see if we can find anything on it. Alright, so what this is a GE 1179, which my ECG book says is a 712, which is a FM and TV sound IF detector. And so what we need to do here is take some voltage measurements. I've got another data sheet printout on this thing, but we're going to take some voltage measurements in the circuit and see what it's doing, if anything. Because I have a feeling that this IC is trash. The fact that we're not getting any sound whatsoever, and that I've already determined that the transformer and the transistor ahead of this are alive. So I'm going to put the thing back together, and we'll put it on an isolation transformer, and then we'll take some measurements and see what we get. But I have a feeling that this little detector IC is the reason why we're not getting any sound. So let's find that out. Okay, so here we are. We've got everything on and running. And I'm just going to check some voltages here at these test points for the obviously the B voltage, the IF, the ground, and all that sort of thing. And we're just going to kind of look and see whether this thing is doing its job or not. Excuse me. Alright, so the first thing I want to look at is pin 5. I hear something. Do you hear something? Ah, see? If I put my phone near the detector, it's picking up all of the disgusting RF noise generated. So let's take a measurement here. This has got the little dot on it, I think. Let's turn the light on. Yeah, so okay, so this is pin 1, which should have diddly squat on it. That's your IF input 1 and 2. Just the same. Pin 3 should be ground, and 4 should be ground, which it is. Pin 5 is 12 volts. So that's about what we're expecting. It's 11.63, but whatever. And then 6 is our volume control. I have 2.6 volts here. 7 is bypass. So there's our audio there. It is passing audio. Otherwise we wouldn't hear that buzz. You can hear it here when I touch my probe to it. Okay. Pin 8 is our buffer output. Yep. Pin 9 is antenna or quadrature network, whatever that is. I guess it's a tuning network of some kind. 11, no connection. 12 is audio out. 12 is audio out. And we're not getting squat from audio out. We've got 3.4 volts there, or 3.8 volts. I don't think that's right. Oh, it's pin 13. That's a tone control. And 14 is audio input, which I get a buzz on too. So the chip is capable of passing signal. I'm kind of confused as to why I'm getting voltage on the output here. I suppose that's okay though, because it's a little bit less than half of what the supply voltage is. So that's okay. And when I touch here, we're getting sound. So the chip is probably okay. The thing to really discover is if we're actually getting IF information, like one of these coils is open or this detector is open. Don't think I should be getting voltage at the detector input here. 1.46. I shouldn't be getting voltage on the detector input. So that could be bad. But I am getting my 12 volts on pin 5. So the chip is being supplied voltage, and we confirmed that it can pass primitive audio. So it's either true that the detector side is screwed up somehow and it's not passing the sound through the IF, or the detector component of this is screwed and the audio amplifier portion of it's still alive. Really hard to tell. I just know that when I apply my probe as a signal, we get the nice buzz. Let's see if that buzz is attenuable. Yeah, it is. If I turn the limiter up and down, it gets louder or softer. If I turn the volume down on the front panel, yeah, that's apparently going past the so very likely this chip is either funky or what's being fed to it is funky. So really, without hooking up a scope, we can't really tell whether it's the chip at fault or the previous thing. So we got to get it hooked up to a scope so we can look at the IF input and see if we're getting our 4.5 megahertz IF signal. If we are, we know the chip is bad. If we're not, then it's something before the chip, at which point it's probably not even worth my effort to try to mess with, because, well, it's a cheap GE set and it's just not worth it. So alright, let's get it on a scope and let's see what we can find. Alright, so here we are back on the bench. We've got our oscilloscope hooked up and we're going to probe out the input pins on the IF. And we've got this tiny little signal here. We've got what looks like 4.5 or 4.3 megahertz. Speed this up a little. Looks kind of crummy though. And let's see. Of course, I'm seeing this everywhere now. So maybe my probe tip isn't grounded correctly. Yeah, not grounded correctly. Yeah, this isn't helping me. Proby. Interesting. Not sure why that's not cooperating. Let's just get back into the audio world here instead of trying to measure the super high bandwidth. Interesting. I just get this gobbledygook on everything. I think that might be how the scope is hooked up. I am on the isolation transformer, so that can't be it. I would have fried my scope by now. Let's just look here. Yeah, no matter where I go, I get this junk here. Even on my scope probe, I get this junk. Alright, let's try a different channel. Or maybe that's the scope picking up something that it shouldn't. Hang on a second. Alright, I think that probe was defective because I'm not getting that junk now. Let's look here. There's our IF information, albeit small. Yeah, there it is. So we got noise. Let's go to our IF input here. We got nothing. Nothing after the detector transformer. Here's before the detector transformer. There's your IF information there. But nothing after. Yeah, if I go on the secondary of the detector transformer, I don't get squat. So that poor thing's open. Yowza. Well, that ain't no good. Yeah, here's the primary side of the detector transformer. There's our IF frequency there. But nothing on the secondary. That explains why the chip passes audio, but there's no sound from the television side, because there's no IF signal getting through here. So this can is bad, which sucks. I don't think it's worth my time to try to mess with it. What I might end up doing is discover where the video amplifier is. Maybe just pipe some video right into it. That sucks. But it's an old set. Sometimes that's how it goes. So I guess what we can do is just use it as a monitor. Or find a way to feed audio video into it. That kind of sucks. But it is what it is, I suppose. Now, I don't know if this will work or not, but I can try jumpering around the can. I think there'll be an impedance problem. But if I can go directly around the can, we'll see if we can get some semblance of audio, and that will definitely prove our theory. Alright, so I've got the volume cranked up on this thing, and here's our test point before the IF can. Let's see if touching some IF to this IC does anything for us. Yeah, it does. You can hear it ever so slightly. You hear the static. There you go. So that transformer's done. What I might do, just as a cockamamie thing, I don't know if I can do this or not. Let's see if it's adjustable with the volume control. If I do this. Not really. Just kind of there all the time. think so. Hang on a second, let me put this down. The other odd thing about this failure is that I have no volume control. When I pipe it into the IC going around the transformer, I have no volume control, even with the volume all the way down. So I kind of wonder if this IC is in fact bad and it's just loading down the transformer, because like I said, I was seeing voltages here at the IF input. I don't think that's okay. I don't think that's right. So I guess the thing to do, let's kill the power on this thing. And realistically right now I just need to order one of these little 712 ICs. They're pretty cheap. I just order it and see what happens. But nominally it looks like this is messed up, because if I take it before the can and I go directly to the audio input of the preamp IC, we get static. Albeit distorted and kind of tinny, but we get static. So we can try replacing this. I think I'm going to take a quick measurement before I go order one and make sure that it's not open. Okay, so taking a measurement across pins 1 and 2, which is supposed to be in parallel with the IF, I get about 2 ohms. So this isn't open like I thought it was. I think this chip is just bad. So we're going to go ahead and order one of those up, and when it comes in, then we'll swap it out and then see what happens. Alright, so there it is. It's a whopping, including shipping, $6.50. And it's the IF limiter detector audio driver, blah blah blah. So I'm gonna go ahead and click buy it now, and then we'll see it when it gets here, pop it in and see if that fixes it. But until now, or until then rather, thanks for watching. More stuff to come.